resting state fMRI to find which parts of the brain correlate with procrastination. All right, so we're going to do a little background first. A resting state fMRI. So it's a resting state fMRI is what you picture like in the movies and doctor shows. The person's slid into this big tube sort of thing, and their brain is scanned. And the resting state fMRI is taken when the person is at rest. So they're not asked to do anything, think about anything, or dream anything. They're just laying there and just being themselves. And what's derived from this scan is a little image, sort of like the one on the right, where the brain lights up in different colors, which correlate to the different levels of activity in each part of the brain. Does that make sense so far? The next piece of technology that we need to know about is regional homogeneity analysis, or the RHO for short. So this essentially takes that same data from the brain, from the fMRI, and it kind of breaks it up into sort of a three-dimensional grid. So each cube would be a little section of the brain. And the way this works is that each cube is compared to its neighboring cubes, so that it can be considered a more active cube, a less active cube, so that, again, kind of figures out what parts of the brain are more active than others. Other than that? Okay. The third piece of technology used in this paper is the amplitude of low frequency fluctuation, or the ALF for short. This, again, shows what parts of the brain are more active than others, but this time it does it by analyzing changes in the brain wave frequencies. And a higher frequency means a more active part of the brain. Okay, so that's all the technology they use. Now we're going to look at the General Procrastination Scale, or GPS for short. So this is a survey of 20 statements. For example, I often find myself performing tasks that I had intended to do days before. And participants rate how true this is to them. So if I really identified with this statement, I would mark it as a 5. If I really disagreed, I'd be a 1. There are a couple faults, though, just as a heads up going into this paper with this method of the self-survey. For example, accuracy. We can't guarantee that everyone's responding perfectly accurately. There's also cultural and societal biases that kind of play into the answer. So for example, Denmark is generally known as like the happiest country, but studies have kind of shown that this is often because it's a societal norm to say you are happy and doing well, even if you might not be. And finally, in this study, there were 95 females and 35 male participants, so that kind of skews the data a little bit as well. So I just threw a lot of information at you. So to summarize, we've got the fMRI. There we go. The fMRI scan over there, the RHO analysis over here with the cubes, and the ALF analysis with the little brain waves. And these three all tell us what parts of the brain are more active than the other parts. And then finally, the GPS is the survey that tells us if you're a procrastinator or a non-procrastinator. So now we're going to dive into the data. But before we do so, I want to make sure we know how to read the figures. So I'm going to take away all that stuff, and let's just look at this figure of the brain. So what this study did, what the scientists did in the study, were they took the people who were the most likely to procrastinate, like the highest procrastinators, so they scored the highest on the GPS survey, and they kind of made a little average of their brain. And so in this brain, we're looking at that little red region right there. There. And as you can see, it's colored bright red, which means, based on the scale below, it is highly active in those who procrastinate or are considered procrastinators. That corresponds to this little graph down here. The x-axis is the GPS scale, so 100 being the maximum highest procrastinator, and 20 being the least procrastinating person. And the ALF scores are showing the frequency in the brainwaves. So as you can see, there's a positive correlation. So the higher you score on the GPS scale, and the more likely you are, the more procrastinator you are, the more likely you are to have this portion of the brain active naturally. Okay, so I'm going to bring back the text. This part of the brain is called the parahippocampal cortex, or PHC for short. And this part of the brain is associated with thinking about the future, which is kind of a broad statement. So more specifically, if there are no negative future effects, you tend to want to have immediate rewards at this moment. So for example, if you're thinking about an essay you have to write that's due on Monday, that's like a future event, you'd want to just kind of relax and like watch Netflix now for that immediate reward, rather than starting the essay right now. Any questions on that? Okay, the next part of the brain that the scientists looked at was the ventromedial prefrontal cortex, or the VMPFC for short, and this is associated with decision making. So specifically, it overrides the activity of the prefrontal cortex, which is self-control. So it overrides the self-control aspect of the brain and focuses on immediate reward again. So just like the previous part of the brain, it's focusing on immediate reward rather than future thinking. And as you can see, there's a positive correlation again. The area of the brain that is the VMPFC is red, so it's more active in procrastinators than non. And there's a positive correlation as your GPS scores increase, the VMPFC is more active. All right. Final part of the brain is the anterior prefrontal cortex, or APFC, and this has to do with long-term planning and reasoning. So you're planning for the best possible outcome in the future. As you can see, this part of the brain is blue, not red. So can anyone tell me, based on this figure, what the correlation of the APFC to procrastination is?
It's a negative correlation?
Yes. Yay, it's a negative correlation. I'm glad you answered that correctly. Okay. So, just to summarize a little bit, we've got the parahippocampal cortex, the ventromedial prefrontal cortex, and the anterior prefrontal cortex, and there's, respectively, a positive, and negative correlation. Okay, so let's add some more brain parts. We've looked at individual sections of the brain, now we're going to add a little bit more. Okay, so we're going to look at the APFC, and it's kind of how it works with other parts of the brain. So to refresh our memories, the APFC is associated with long-term planning and reasoning, and it has a negative correlation. So as you think about the future more and like plan out, you're less likely to procrastinate. So that was, on its own, a negatively correlated part of the brain. So as you procrastinated more, this part of the brain was less active. However, when the APFC is working, okay, so that little underscore shows the APFC working in conjunction with the part of the brain called the PCC. And this, like, what that part of the brain does isn't really significant to this data, but what is significant is that when working in conjunction with this part of the brain, the correlation is now positive. So now when you procrastinate more, this part of the brain is more active. So this kind of debunks the theory that every part of the brain has a specific use and a specific role. And it kind of lets us know that maybe we do need to research a little bit more into these brain functions and how they work with each other as well as individually. Okay, so the results to summarize quickly. The PHC is the thinking about the future part of the brain, and there's a positive correlation. The VMPFC is decision making, and again, has a positive correlation. And those two were the sort of reward now instead of in the future. The APFC is long-term planning and reasoning, which is a negative correlation. However, the APFC working in conjunction with other parts of the brain have a positive correlation. So, future implications. Clearly, there need to be more studies because, like the previous figure showed, the parts of the brain working in conjunction have different functions than working alone, so we kind of have to figure that out. Brain's pretty complicated, so there's definitely a lot more knowledge we can amass from that. Once they do have a better sense of the parts of the brain and how they interact, cognitive training programs to override the overriders can be implemented. So, for example, when the APFC worked with other brain parts, the correlation became positive. So if we can think in a way that utilizes the APFC by itself, it's possible that we can make that correlation negative again. And another solution for procrastination are potential medicines to target those same parts of the brain. So I know that like procrastination doesn't seem like that big of an issue that needs like medical and mental like treatment and stuff like that, but it's shown that procrastination really does impact quality of life in people. So that could be a giant step to the future. Any questions? Thank you.